So the first thing I would recommend is set up your long division. In America, the way we teach long division is you take whatever you're dividing into and you put that underneath the house, right? So that's all going to go under here, and then whatever you're dividing in with, that goes in front. If you have a different way of doing long division from a different country, I'm not going to make you relearn my way. So feel free to do it the way that you know how, as long as you get to the right place. Okay. 3x to the fourth is my first term, so I would write that. Now, convention is either leave a gap or write 0x to the power when you have a missing term. For example, here I go from 4 to 2. If you just put negative 6x squared right next to this, you are prone to make mistakes when you're doing your second step. So I highly recommend at least leave a space, but some people prefer just to write 0x cubed as like a filler here. Then negative 6x squared, positive 3x, minus 7. That's the only term that got skipped. Okay, the process, or the algorithm, if you will, for long division was look at the leading terms only as your first step. And ask yourself, x times what would give me 3x to the fourth? 3x cubed. And convention, I like to line things up. It's just about being organized here. So 3x cubed, I would put like right there, just convention. Second step, multiply that term that we just wrote on top by everything in front. And write them under the appropriate terms. Stack like terms together. So 3x cubed gets multiplied by x and then by 1. Well, wouldn't that be 3x to the fourth and positive 3x cubed? Then I would subtract in my next step in the algorithm, which really means draw the line and distribute the negative sign. Draw the line and change every sign.
Wait, why did you add 3x cubed?
I have to multiply by everything in front. So I did 3x cubed times each term. Now the next step of long division is subtraction. So you draw the line and subtract every term, which means change every sign. So had this been a negative, he would have become positive. In this case, he was positive, so he becomes negative. Watch your sign right here. That's usually where students make their arithmetic mistakes, computational errors. At this point, if you built it correctly, if you're doing the algorithm correctly, the first term should cancel. Death to you, death to you. Now I have a 0 minus 3 if I have it correctly written. Notice, had I not used that placeholder, I might have accidentally combined two things which were not like terms. That's why we prefer you use a placeholder. So this produces negative 3x cubed. And now I get to repeat the algorithm. Leading term with leading term. The next term could come down for the fun. So bring them down, negative 6x squared. And you begin the process all over again. You ask yourself, x times what would give me negative 3x cubed? Well done. Negative 3x squared is correct. Repeating the algorithm, we multiply that term by everything in front, producing negative 3x cubed, which is what we wanted, and a negative 3x squared. Again, I have to watch my signs very carefully here. The next step of subtraction requires drawing my line, but changing my signs. This becomes positive, this becomes positive. So watch those signs. If I did it right, these should cancel in first, death to you, death to you. Negative 6x squared, positive 3x squared produces negative 3x squared. If you had the wrong sign, you would have had negative 9x squared there, and totally wrong problem. Okay. Bring down your next term and repeat the algorithm, only looking at the leading terms. We ask ourselves, x times what gives me negative 3x squared? Negative 3x. This is kind of a boring one, sorry. It's always a very simple one. Then we repeat that algorithm and distribute to every term in front. We are officially out of time, so if anyone has to leave, you may. I'm just going to finish the problem for those who would like to stay. This gives me negative 3x squared, negative 3x. I will draw my line and change every sign. Death to you, death to you. If you didn't get this sign right, you would have canceled, wouldn't you? But now it's actually 6x. And finally, I would bring down my last term and repeat the algorithm one last time. X times what would give me 6x? Positive 6. Distribute 6 to everything in front gives me 6x plus 6. Oh, we're super close to canceling, but no cigar. When I draw my line and change my signs, I actually end up with negative 13 as my remainder. My quotient would be this piece. If they ask you in my math lab for them separately, that's the quotient, that's the remainder. Because the remainder does not equal 0, I can now say this is not a factor. Next class, if you wouldn't mind, before next class, could you do A by yourself and we'll pick up there. We'll also learn another shortcut called synthetic division, which works only in some cases. Okay, you are dismissed. Good luck to you.